So part 4 is to program part 3 and include the hex 0 and switches switch 0 through 17. So essentially all the switches, and hex 1 and 7 should be off. Hex 0 should just display 0 at the start. And if the switch is set to high, it's kind of like, this part is kind of like a game. So every time the switch and the LED's value matches, then the 7 segment display will display a value for that, for essentially matching the LEDs with the switch. So since this is on falling edge, every time you have to have the switch up high, and then it will check based off of when you put the switch back down. So for example, if LEDR 2 is on and you flip switch 2, the counter should go to 1. So I'll explain the coding portion. So here we clear everything, initialize the timer, initialize the keys. We also have the keys as we're programming part 3, so we still have the keys shifting the LEDs. It's the same exact code from part 3. All we're adding now is interrupts for all switches to do that. So the LED should be shifting left and right, and it should be shifting at certain intervals that you set it at, or it's defaulted to 1 second. So here's the timer, here's the timer ISR, so that doesn't change. The only thing that changes now is that we have the switches, so we are checking from 0 through 17, and then making sure you clear the edge capture for the switch, and also to register the interrupt handler for the switches. So this is for all switches. It will also be very similar to the last program where we put everything straight into the button interrupts. So we handle the button interrupts here. As you can see, the edge capture points to the certain switch value, and this is the most significant bit value of the switch that gets activated. So anything else will not trigger the interrupt, or at least the edge capture, and it will not go to switch ISR. So once it goes into switch ISR, like I mentioned before, make sure you clear your edge capture register for both. I'm changing this to 5 seconds. Make sure you reset the edge capture register for both of the keys and the switches. It goes into the corresponding keys ISRs, and then our switch ISR, it will be here. So it's going to load the switch value, and then make sure you clear the edge capture. Then if the switch, this is really easy, because if you think about it, since you have your timer running always, there is in the timer ISR, there is a count value. Let me just mute that. There's a count value here that's always getting the most significant bit. It's to the power whatever the index is, so whatever position is, right? So you check your edge capture, and then you essentially checking if it's the same value. Where's my switch ISR? So if it's the same value as count, then your hex counter, which you'll have, this is a global variable, your hex counter is going to increment. If not, then it just says that the switch value is not the same, and then reset the edge capture. So this is pretty straightforward. I also realized it's only supposed to show hex 0, so you can actually just not display this. I'm gonna comment those out, and then make sure that hex 0, yeah, this is all cleared. Okay, so this should work properly. I'm going to run it, and then we'll show the demonstration on the board. Okay, so my code is running now. So basically, what is going to happen is that the hex is here displayed, and the lights, the LEDs are all here, it's doing the normal thing. If I flip anything else, it shouldn't count on the counter, so it's not lining up the LEDs. So let's actually increase the speed of this. Actually no, let me just slow it down a little more. So I'm gonna go LEDR 7, so I'll just have it ready, and then bam. So it should be 1. And then I can do another one. So I'll make it wait till it comes back. I'll do 5. And then oh, I missed again. Okay. It's a little too fast for me. I think because I'm watching the recording. No, actually. Okay, I got this. So there it's showing 2.